Hey guys, so today we're going to talk about how to figure out the percent of a number. So this is lesson 2.7, percent of a number. So again, we're just trying to figure out a part of a bigger or a smaller number, doesn't matter. So I'm just going to lay out a problem for you. So something like 57% of 12. Okay, so when we see this word of, we need to take it to mean multiplication. Okay, now, the way that this problem is written, there is an issue. What's that issue? You can't multiply by a percent. So there's no math we can do when there's a percent number. So we're going to have to do a little bit of some alteration. So we're either going to change the percent to a decimal, okay, which is probably the fastest thing. Remember, we just move the decimal left twice. Okay, that's all it takes, and then you just multiply, right? Or the other option is to change the percent to a fraction. So that means you would take the percent number and you'd put it over 100. And sometimes, and we may not get a nice even answer, that's okay. So that's just, those are your two choices. So let's remind ourselves about topics we dealt with before. We dealt with multiplying fractions. So if I create a fraction from my percent, then I'm going to have to create a fraction for the number after the word of. So what you're going to do, and this is my favorite thing to do, and you know I've talked about this a lot of times, try to cancel out common factors of any numerator and any denominator. Now the reason why I say that is we're used to just looking on the diagonal with a numerator and a denominator, but sometimes inside of a fraction it can get reduced, okay? All right, so let's say we've done that, so what happens next? Well, we're just going to multiply straight across. And if you don't want to try to cancel out first, then you can do it later. So that means numerator times numerator. I can't believe how big these words are. For a small little thing like a fraction, its parts have super long names. And then we're going to multiply the denominator times the denominator. Okay, so that's our step 1, and then step 2 would be simplify if possible. So again, look for any common factors you can divide out. Okay, and then we may end up having to multiply decimals again. So reviewing our 3 and 4 chapters. So there's a couple of different ways we can do this. So the first thing I might even think about doing is to start by figuring out how many decimal places my answer is going to need. So to do that, I'm going to count the number of digits. Those are individual one-digit numbers. Come after the decimals in the original numbers. We're just going to kind of hold on to that number. We can write it down. I like to make dots, and so then I count up the dots when I'm ready to put my answer in. Once I do that, I'm going to multiply the numbers as if the other D word, decimals don't exist. Okay. And then the last thing is we got to put that decimal back in. So then we're going to answer will have the same number of digits after the decimal that were counted in step 1. Okay? All right, so I'm going to go ahead and, let's talk about a couple other things. Remember how we took some notes in 2.4 about what if we have these really large over 100% and under 1%? So let's talk about how we would handle that. So let's talk about percents greater than 100%. So if I have like a 3-digit percent of a number, what is the best way to deal with this? And I'm going to suggest that you try changing the percent to a fraction. The reason why I'm going to suggest this, so that would put the percent number on top and 100 on the bottom, is because when you start getting these larger numbers and then you involve multiplication, that's where most people start getting like stressed out about it, okay? If I have fewer numbers, when I multiply, it's not as bad. So like a 2 digits by 2 digits, not so bad. But when I start involving 3 digits, now we start getting a little bit stressy. So that would be my suggestion of what to do if we have a percent that's greater than 100. Go ahead and just make it that percent into a fraction. But what if the percent is less than 1%, so really small? Well, then at this point, I would suggest that you try changing the percent to a decimal. And this is real easy. Remember, all you do is move the decimal left 2 places, because you're dividing by 100 this way. Whereas with the percent that's greater than 100%, you're dividing vertically, dividing by 100 vertically. Uh-oh, I hear a monster coming our way. All right, let's do some problems to practice. So let's say we wanted to figure out, let's just say directions are going to ask us to find the percent of each number. Okay, so number one, let's say you're asked to find 15% of 300. Okay, now look at 300. It ends with 2 zeros. What else do we know that ends in 2 zeros? The answer is 100 does. So I probably would opt to change 15% to 15 over 100. So now my problem becomes 1500, and then of means to multiply, and then we're going to have 300 over 1. So I'm going to look on the diagonals, and I know that 100 goes into itself once and into 300 3 times. So when I multiply, excuse me, I get 15 times 3 is 45 over 1, which simplifies down to 45. And that's it. That's how we get an answer. Okay, let's take that same problem, and I'm going to show you with a decimal, and you kind of decide for yourself what do you think works best. So I'm going to take 15%. I'm going to change it to a decimal. So I'm going to drop off the percent sign and move the decimal left. So that's going to give me 0.15. So then what I end up doing is taking the numbers and multiplying. Now, all I need to remember is between these two numbers, there's 2 digits that come after the decimal point. So I get 0 times 0, I get a 15 placeholder, 1 times 0, 1 times 0, 1 times 3. Add those up. Now I got to remember, I'm going to have 2 digits after the decimal point. So what's my answer end up to be? Same exact answer, 45. Notice percent is gone. Why? Because I convert the percent to either a fraction or a decimal, and then I multiply. Okay? So you get kind of a choice how you want to solve this. All right, well, let's say we have something like this. 145% of 320. So again, if I have greater than 100%, the suggestion is that I'm going to take the percent and change it to a fraction. So I'm going to divide by 100 horizontally like that. Division, of means to multiply, and then I'm going to write 320 over 1. Now, I know there's a 10 in common on the diagonal because 100 and 320 end up in a 0. So I'm going to divide out a 10. So that's going to leave me a 10 here and a 32 here. And then I'm looking at the 145 and the 10, and I notice that they have a 5 in common. So 5 goes out here. Now 5 goes into 14 twice, which is 10 with 4 left over, and 5 goes into 45 9 times. Now let's see. Oh, I did something wrong there, didn't I? Yep. Oh, no, he's fine. What I did wrong was here, and I said 10 divided by 5 was 5, and 10 divided by 5 is 2. Now look on the diagonal, 2 goes into itself evenly, and into 32 goes into 3 once with 1 left over, which gives me 12, and 2 goes into 12 6 times. So I know that's a lot of simplifying, but what it did do is make my numbers get down to be 2-digit by 2-digit. Now 9 times 6 is 54. 9 times 2 is 12. 12 plus 5 is 17. Put in a placeholder, and I get 1 times 9 is 9, 1 times 2 is 2. Add up, you get 400 264. That is your final answer. So yeah, when we have these really big numbers, maybe even the really small numbers, and we end up having a bit of a mess to deal with, okay? So let's see. Let's do another one like this, and then, I'm going to show you a really weird one. 275% of 4. So again, I'm going to turn that percent into a fraction. 275 over 100. Of means to multiply. And I'm going to turn 4 into 4 over 1. Now I'm going to look for things I can cancel. I'm going to change my colors this time. And let's see, 4 goes into itself once and into 125 times. Now what I am left with is dividing 25 into 275, and I think it goes in all the way. So let's see, it goes in once. Yeah, it does. Thought that looked familiar. It goes in that once. So my answer works out to be 11. All right, let's try a couple of small ones. We have 85/100ths% of 600. Okay, so this is the one we said, hey, we've got this decimal, let's just go to decimals. So I'm going to divide horizontally, and that's going to give me 0.0085, or 85/10,000ths. Of means to multiply, and then we have the 600 is still there. So what I'm going to do is I'm going to count how many digits come after the decimal point and just take a note. 1, 2, 3, 4. So I'm going to remember this number 4. That looks like a 14. All right, let's just erase that and start all over again. 4. Okay, so now what I'm going to do is multiply 600 times 85. So I'm going to eliminate all those extra zeros there. So I get a 0, a 0, 30. Put in a placeholder, 0, 0, and 48. Add up 1, 2, 3, and then we've got an 11 and a 5. So now I need to take that decimal point and move it back so that there's 1, 2, 3, 4 digits after the decimal point. Now, what I don't need in my answer are all these zeros. Why? Because they just mean nothing. So what I'm left with is 5 and 1/10. Okay, that's a very small number. When you look at 600, all right, let's do one more like that. 55% of 220. So again, we're going to start by moving the decimal point left twice. That's dividing by 100. That's going to turn my 55 or 0.55% into 0.0055, or 55/10,000ths. I still have times, and I've got 220. So I'm going to do my counting, so I have that ready to go. 1, 2, 3, 4 digits after the decimal point, so I'm going to remember that number. And now all I'm going to do is multiply 220 and 55. So 0, there, we get a 10. 10 and 1 is 11, put in a placeholder, and we're going to get exactly the same numbers again. 0, 10, 10 and 1 is 11. So we have a 0, a 0, 1, 2, 1. But now we got to remember to move that decimal point. So we're going to go 1, 2, 3, 4. We're going to eliminate those extra zeros, and my answer is going to be 1 and 21/100ths. And there you go. And that's what we'll be practicing together on Wednesday. All right, good luck now.